Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today in this video, I am going to discuss about question bank on Module 2. What is the Module 2? Module 2 is second and higher order ordinary differential equations. So here what are the formulas or what are the methods we used here? Just I want to recall the formulas of this Module 2. So if you are having the form f of t into y equal to q of x. So here what we are going to solve this here, how we are going to solve this equation. So by using this form, first we need to calculate about the f of d value. So by using this f of d, we are going to write the auxiliary equation, that is f of m equal to 0. From this we are going to find the roots. After that we are going to find the complementary function. So if it is homogeneous equation f of d into y equal to 0, then only complementary function is the general solution of the given equation. For example, if it is not the homogeneous, if it is f of d into y equal to q of x, then this is the non-homogeneous equation. Here how to solve this equation is, first we have to calculate the complementary function and we have to calculate the particular integral also. Then the complete solution is complementary function and particular integral. This is the general solution of the non-homogeneous equation. So here two important points you have to remember. If it is the homogeneous equation, only complementary function is the general solution. If it is non-homogeneous equation, complementary function and particular integral is the general solution of the given equation. So for this we are having some formulas in place of q of x. That means if it is non-homogeneous equation, in place of q of x, if you are having e power ax, what are the formulas we are going to use? If it is sin of ax plus b or cos of ax plus b, otherwise sin ax or cos ax. If you are having in place of q of x, what are the formulas we are going to use? And if you are having q of x value or f of x value is x power n, what are the formulas or what is the procedure we are going to follow here? And after then, if you are having e power ax into g of x, otherwise e power ax into v, what are the formulas we are going to use? These are all formulas, and including these methods, we are having one more method, that is method of variation of parameters for finding particular integral. These are the all formulas we are having in the module 2. Just I want to recall all formulas first. After then I am going to discuss about the question bank questions. So here particularly about the non-homogeneous equation. So non-homogeneous equation is f of d into y equal to q of x, or here in place of q of x we can write f of x. So in place of f of x, first if you are having e power x, what is the formula or what is the procedure we are going to follow here to find out the particular integral, that is 1 by f of d into e power ax. So here in place of d we can replace the a, that means put d equal to a. Put d equal to a. So that means in place of d we are replacing a here. So 1 by f of a e power ax. Then f of a should be not equal to 0. So if f of a is not equal to 0, up to this problem is finished. So finally we can write the solution also. If f of a equal to 0, then what should I do? So here if f of a equal to 0, we have to follow this procedure or this formula. So x into 1 by f dash of t into e power ax. After taking the differentiation of the f of d value, f of d is nothing but the equation form in terms of d, right? So after differentiating the equation, we have to replace the d value again. Then f of a value should be not equal to 0. Then we can finalize this answer as a particular integral. For example, if f of a is also 0, Then again we have to follow this one, x square into 1 by f double dash of a into e power ax. Then f double dash a should be not equal to 0. Like that, if you are getting f double dash of a also 0, then we can go for the triple dash. Like this, we have to follow the formulas if you are having f of x value is e power ax. For example, if you are having f of x or q of x value is sin ax or cos ax. Here, we are going to follow the method. So, we have to replace d square equal to a square. Here, in place of d square, we have to replace minus a square. So, here, if you are taking minus a whole square, then a square will be positive. But here, they are telling that minus a square. That means, after taking the square, after taking the square term, then we have to take minus. That means, this is the negative value we are going to replace here. So, particular integral of this is x into 1 by f dash of minus a square sin ax plus b or cos of ax plus b. Then f dash of minus a square should be not equal to 0. So, if it is f of minus a square is equal to 0, we are going to follow the next formula, that is x square into 1 by f double dash of minus a square sin ax plus b or cos ax plus b. So, here if q of x value is x power n and n is a positive integer. So, if up to now we discussed about the formulas, if f of x value is e power ax or sin ax or cos ax, and next one is x power n. So, if you are having x power n, what is the formula? How to convert the given equation form? See here, particular integral is 1 by f of d into capital F of x is equal to 1 by f of d into x power n. So, if you are having that value, q of x value or f of x value is f power n, then we have to convert the given equation like this, that is 1 plus or minus pi of d. So, here 1 plus or minus pi of d means we have to write this one as a inverse form. Then, we are going to expand this one by using the binomial theorem. So, up to the nth degree. So, here we are going to use the expansion by using the binomial theorem. We can observe here. So, if you are having 1 plus x whole inverse, we can write this one as a 1 minus x plus x square minus x cube plus and so on. Alternatively, plus and minus and 1 x square x cube like this. If you are having 1 minus x whole inverse, here also minus and power also minus. That means here we are going to get all positive values. So 1 plus x square plus x cube plus and so on. So having power minus 2. Then 1 plus x power minus 2. This will be 1 minus 2x plus 3x square minus 4x cube plus and so on. So 1 minus x whole power minus 2. Then 1 plus 2x plus 3x square plus 4x cube. These are the formulas we are going to use to expand the given equation form. And one more method is there. If you are having, up to now we are having the single terms, right? In place of q of x or in place of f of x, we are having the single terms, that is x power n and cos ax or sin ax and here e power ax. Now we are having the multiple terms with the a power x. E power ax into g of x or e power ax into v. If you are having the form like this in place of q of x or f of x, what is the procedure or what are the formulas we are going to follow? Here you can see. So here the rule is 1 by f of d into e power ax into g of x. So here e power ax into, first we have to take it out, e power ax form. After then in place of d we are going to replace the t plus a. In place of d we are going to replace the d plus a. So after then what is the next step you have to do? So based on the g of x value, otherwise based on the v value, if it is x power n, we will follow the procedure by using the x power n formula. If you are having cos ax or sin ax, we are going to use that formula. And if you are having other value, so based on that we are going to follow the procedure here. So first step is we have to take e power ax out, and in place of d, we have to replace the d plus a. So, based on this g of x value, so we are going to follow that procedure. And one more important method is there in this second module, that is method of variation of parameters. So what is this method? This method is method of variation of parameters. Why we are using this method? To find out the particular integral. So for what purpose we are using, we are finding the particular integral to get the general solution for non-homogeneous equation, to get the general solution for non-homogeneous equation. So here you can observe the method procedure. So consider the second order linear differential equation, that is d square y by dx square plus p into dy by dx plus q into y equal to f of x. So otherwise you can replace here q of x also. So here the important thing is first complementary function. So complementary function gives us complementary function equal to c1y1 plus c2 y2. So here by using the complement function we are going to assume the particular integral. So here y1 and y2 are the two independent solutions. So here we are going to find out the second step, that is Wronskian value, that w is. So here we are taking the independent solutions, those are y1 and y2, and derivatives of those solutions, that is y1 dash and y2 dash. After calculating the Wronskian value, so we are going to compute the u1 or a value. Sometimes we are denoting with the u1, sometimes we are denoting with the a also in the some of the textbooks. So there is no confusion about this. So we can denote with the u1 also, otherwise you can denote with the a also. So u1 equal to, otherwise a equal to minus integral y2 f of x by w, otherwise you can take it as minus integral u into q of x by w. So here if you are taking u2 equal to integral y1 f of x by w, here first solution is u, if you second solution is v, then we can write here v. So according to your assumption, you have to remember. So here I am taking this one as a b equal to integral y1 is the first solution, this is u, q of x by w. So what is the w? W is the Wronskian value, that value of y1 and y2, that value of y1 and y2. So after calculating the a and b, or after calculating the u1 and u2, we are going to find the particular integral, that is u1 y1 u2 y2, otherwise a into u plus b into v. This is the particular integral. So already we calculate the complementary function and particular integral. We can write the final general solution, that is y equal to complementary function plus particular integral. These are the methods and these are the formulas we are using in the module 2. So we are going to discuss some of the questions in the question bank. So here in the question bank we are having the two parts, part A and part B and part C. So in the part A we are having the problem solving and critical thinking questions, and part B we are having the long answer type questions, and part C we are having the short answers. So here part A we are going to discuss about part A problems, and after then we are moving to part B. So see here the first question they given, solve the differential equation. What is the differential equation? D square plus 1 into y is equal to sin 2x. What we have to do here? We have to solve this differential equation. So first of all we have to compare this equation with the equation form. This is in the form of f of d into y equal to q of x. What is the f of d here? F of d is d square plus 1, and here q of x value is sin 2x. Q of x value is sin 2x. So first of all this is the non-homogeneous equation. If it is non-homogeneous equation, what is the general solution? That is y equal to complementary function plus particular integral. So from the f of d value we are going to calculate the complementary function. From the q of x we are going to calculate the particular integral. So how to find the complementary function here? First we have to write the auxiliary equation, that is f of m equal to 0. That implies m square plus 1 equal to 0. So m square equal to minus 1. M equal to square root of minus 1, that is plus or minus I. So we are having the two roots here. M1 value is I and M2 value is minus I. So like this we can write this is the alpha plus or minus I beta. So alpha value is 0 and beta value is 1. So here, based on this, we can write the complementary function. What is the complementary function? If roots are complex, the complementary function is e power ax. What is the a value here? Or alpha value. So here e power alpha x. So 0 into x and c1 cos beta x. Beta value is 1. So cos x plus c2 into sin x. So e power 0 is 1. So complementary function is c1 cos x plus c2 sin x. So this is our complementary function. So after that, by using the q of x, we are going to calculate the particular integral. So particular integral equal to here q of x value we are having sin 2x. So here a value is 2. So if you are having sin 2x, what is the particular integral we are going to find? So that is 1 by f of d into q of x value. What is the q of x value is? Here 1 by f of d value is d square plus 1. D square plus 1. Here q of x value is sin 2x. And here what is the a value? Sin ax, right? So what is the a value is 2. So here in this method, if you are having q of x is sin 2x, we have to replace d square equal to minus a square. What is the minus a value here? Sorry, a value here 2. So minus a square is 4. So now we are going to replace here. So particular integral equal to 1 by d square value is minus a square. So minus 4 plus 1 into sin 2x. So what is this value? Minus 1 by 3 into sin 2x. This is the particular integral. So already calculated complementary function and particular integral. So what is the general solution? General solution equal to complementary function plus particular integral. So what is the complementary function? That is c1 cos x plus c2 sin x plus here minus 1 by 3 into sin 2x. This is our general solution. So this is the way if they given the any differential equation to solve by using the methods based on the q of x value. So see the second question. Second question is apply the method of variation of parameters to solve the equation, that is d square minus 2d into y is equal to e power x into sin x. So here already I explained before, if you are applying the method of variation of parameters, we have to follow the sum of the steps here. So first we have to calculate complementary function. Finding complementary function is as it is. By using the f of d value, we can write f of m equal to 0. After then we can write the complementary function. So here we are having m square minus 2m equal to 0. So this one is we are taking m common here. So m into m minus 2 equal to 0. So m equal to 0 and m equal to 2. So m values are we are having 2 based on this. These two are real and distinct. So complementary function is c1 into, what is the complementary function? c1 into e power 0x plus c2 into e power 2x. So this is c1 e power 0x is 1. So plus c2 into e power 2x. So here complementary function c1 plus c2 into e power 2x. So this is our complementary function. After finding the complementary function, in the method of variation of parameters, we have to assume the particular integral. So here we are assuming particular integral equal to a into, here what are the solutions we are having? U equal to 1 and v equal to e power 2x. So here we are assuming a into, in place of c1 we are replacing a. So a into 1 plus b into e power 2x. Now we are going to calculate the Wronskian value. What is the Wronskian value? U, V and U dash, V dash. What is the U value? U value is 1, V value is e power 2x and U dash is 0. E power 2x is 2 into e power 2x. Now this Wronskian value is 2 into e power 2x minus 0. Finally this is 2 into e power 2x. This is the Wronskian value. This is the Wronskian value. So after you calculating the Wronskian value, we can calculate the a and b value. So what is the a value? A is minus integral v into q of x by w. What is the v value? So minus v value is e power 2x. So e power 2x into, so here this q of x value, what is the q of x value? We are having e power x into sin x. So e power x into sin x by Here, what is the Wronskian value? Wronskian value is 2 into e power 2x. So, e power 2x, e power 2x will be cancelled. Finally, we can integrate this function by using the integral by parts. Then we can calculate the a value. In the same way, we can take the formula of the b. That b formula is integral u into q of x by w. By substituting these values, we can integrate this function. Then we can get a and b values. We can replace here to get the particular integral. So already we know the complementary function and particular integral. Together we can find the general solution. So now see the third question. Here also we are using the method of aeration of parameters, that is d square y by dx square plus y equal to cosecant x. This is cosecant x. So here we can write this one in the f of d form, that is d square y plus y equal to cosecant x. D square y plus y equal to cosecant x. So here d square plus 1 into y is equal to cosecant x. This is in the form f of d into y is equal to q of x. F of d into y is equal to q of x. Now here f of d value is d square plus 1. So from this we can calculate the complementary function. So after that we are assuming the particular integral. So what is the complementary function based on this? M square plus 1 equal to 0, m square equal to minus 1. So m equal to plus or minus I. So what is the complementary function here? So e power 0x. So that is 1. So c1 cos x plus c2 sin x. This is the complementary function. So now we are using the particular integral. What is the particular integral? A into cos x. So that means in place of c1 we are taking a plus b into sin x. This is assumed particular integral. So from this we are going to calculate a value and b value. What is the formula for a? A is minus integral v into q of x by w. V is nothing but, here the solution is u equal to cos x and v equal to sin x. So here v value is sin x and q of x value already we know, that is cosecant x. From the given equation we can write. And w value, what is the w value? W value is Wronskian value. Already we know the formula for the Wronskian value, that is w equal to that of u v and u dash v dash. So we are writing this that value. So we can calculate the w and we can replace here to get the a value. After that, in the same way, in the formula of b, that is integral u into q of x by w. What is the u value? U value is cos x and q of x value is cosecant x by Wronskian value. We can calculate the b. So already we know a and b. So finally I can write the particular integral, that is equal to a value we replaced into cos x plus b value we replaced into sin x. So like this we can calculate the general solution of the given equation by using the method of aeration of parameters. See this one. Find the general solution of y power 4 plus 8 into y double dash plus 16 into y equal to 0. So that means y power 4 plus 8 into y square plus 16 into y equal to 0. So this is in the form of, this one is d power 4 plus 8 into d square plus 16 into y is equal to 0. So this is in the form of f of d into y equal to 0. Nothing but this is the homogeneous equation. This is homogeneous equation. If it is homogeneous equation, what is the general solution? General solution is only complementary function. That means to find the complementary function is enough for the solution. So finally what is f of d value? F of d value is d power 4 plus 8 into d square plus 16. So from this we are writing the auxiliary equation, that is f of m equal to 0. So m power 4 plus 8 into m square plus 16 equal to 0. So for this equation we are going to calculate the roots. After then we can write the complementary function. So here we can use the calculator also to find out the roots. And otherwise already we know the procedure. We can do this general calculation here. M power 4 quotient is 1, and here m cube is not there, so that quotient is 0, and m square quotient is 8, and m quotient is 0. Here we are not having the m quotient, so that constant is 16. Now randomly you have to check about the roots here. If you are taking 1, so here we have to take initially 0. So 1 plus 0 is 1. So 1 ones are 1. So here 0 plus 1 is 1 again. 1 ones are 1. So 8 plus 1 is 9. So 1 nines are 9 here. So 0 plus 9 is 9. 1 nines are 9. So here at the last we should get the 0. Then only that is the root of that equation. So plus 1 we are not getting. In the same way we have to check about the minus 1. If we are getting 0, then we have to take this is as a root. Otherwise again we have to take 2 after then minus 2, like this. Randomly we have to check all the values to get the roots. Otherwise if you know the calculator properly, you can use the calculator to find out the roots. Then we can write the general solution of this equation very easily. See this, solve the differential equation, that is here the same way y power 4 and 18 into y square plus 81 into y is equal to 64 into cos x plus 108 into cos 3x. Before we are having the homogeneous equation, that's why only complementary function is enough. So here we are having the q of x value also. So that means we have to calculate the particular integral also. So in the same way what I explained before, we have to take f of d value and after then write the auxiliary equation to find out the complementary function. So after finding the complementary function, we are going to calculate about the particular integral. So for the q of x value, what they given? Q of x equal to 64 into cos x plus 108 into cos 3x. So here 64 is the constant and here we are having the cos x. That means if we are having cos x means we have to use the formula. In place of q of x we are having the cos x. So what we are going to write? That is, first of all, what is the formula for the particular integral? 1 by f of d into q of x. First you have to write that one. So 1 by f of d value is d power 4 plus 18 into d square plus 81 into d. So this is our f of d. So here what is the q of x value? 64 into cos x plus 108 into cos 3x. So now we have to simplify this equation. First I am separating the terms here. So 64 is the constant, taking out, and 1 by d power 4 plus 18 into d square plus 81 into d into cos x plus, and here 108 is the constant, taking out, 108 into 1 by f of d value same into cos 3x. Here we are having q of x value is cos x and here we are having cos 3x. So that means a value is 1 here, here a value is 3. So here we have to replace d square equal to minus a square. In the first term, d square equal to minus a square value is minus 1. In the second term, d square equal to minus a square value is minus 9. So we have to put these values in place of d square. Then we can get the solution here. That is the particular integral of the given equation. So already calculated complementary function, we can find the particular integral. Together is the general solution of the given equation. So as like a third and fourth problem, here in the sixth one also we are using here method of variation of parameters. That given equation is d square plus 4 into y is equal to secant 2x. So f of d value is d square plus 4 and auxiliary equation is f of m equal to 0. So m square plus 4 equal to 0. So m square equal to minus 4 and m value is plus or minus 2i. So here by using these values we are going to write the complementary function. Complementary function is here alpha value is 0. So e power 0 is 1. So c1 cos 2x plus c2 sin 2x. So this is the complementary function. So now what about the particular integral? Particular integral is we are going to use here. So that is 1 by f of d into q of x value. So what is f of d value? F of d value is d square plus 4 into secant 2x. D square plus 4 into secant 2x. So here, so like this we can find the particular integral also. So finally, what is the general solution? General solution is complementary function and this value plus particular integral. So in the same way, we can calculate the method of seventh problem by using the method of variation of parameters. So here we are going to assume here actually we can calculate this particular integral by using the general method. So in the method of variation of parameters, we are assuming the value by using the complementary function. So here also in the 8th one, method of variation of parameters, as like a previous 6th one and 7th one, we can calculate the complementary function. So that is C1 into cos x plus C2 into sin x. For example, if you are having particular integral, we have to assume here A into that cos x plus B into sin x. So by using this value, we are going to calculate A and B value. Then we can substitute here to get the solution. And here by using the method of variation of parameters, here d square minus 60 plus 9 into y equal to e power 3x by x square. Here we are having the q of x value, right, e power 3x by x square. If general method is there, we are going to follow the e power ax into v formula. But here they are asking the method of variation of parameters. So we have to use that formula to calculate the general solution. Here also we are using the method of variation of parameters. So we can calculate a complementary function and after then we can assume the particular integral. So here see the differential equation. This one is 2 into cos of 2x plus 3 plus 2 into e power x plus x square. So here we can use the formula for the cos ax formula. That means we can replace d square equal to minus a square. And here we have to use the formula for e power ax. That means how to calculate this particular integral. We can see this particular integral equal to 1 by f of d into q of x value. So here q of x value we are having the 3 terms 1, 2 and 3. So we have to split this one. So first term and second term and third term. In the first term we are having cos of 2x plus 3. Second term we are having e power x. And third term we are having the x square. So here we are going to follow the formula for the d square equal to minus a square. So here we are going to use d equal to a formula. And here we have to convert the given equation into the form of 1 by pi of d. And we can expand this one by using the binomial expansion. So here also we are having q of x value, that is 96 into x square and plus sin 2x minus k. So here some of the students having the question about the minus k means this is the constant. This is the constant. Already we know this is the 96 is the constant. For the x power n formula we can follow here. Here we can follow the sin ax form. We can follow the sin ax form. But here we are having only constant. So that's why we are going to write here e power 0x. E power 0x. So in place of power, if you are replacing it 0, then this value becomes 1. So this is 1 into e power 0x. So k into e power 0x. So we have to follow the formula for the e power ax here. So in this one also same way we can follow. And fourth one also. So e power 2x and e power minus 3x is there. So we are going to follow the formula like e power ax. So like this we can solve these questions. And one more different question is there here. Sin x and sin 2x. This is in the form of sin a and sin b. So here we'll take 2 sin a sin b. We are having the formula for the 2 sin a sin b. 2 cos a cos b. These are formulas, trigonometric formulas we can use. Trigonometric formulas. So here we can use sin of a plus b plus sin of a minus b. Or sin of a plus b minus sin of a minus b. By using these formulas, we can split this value as a 2 terms. So after then, we can apply the formula of sin ax. So here in the same way, we are having 3 into 3 plus 5 into e power x. So e power x form we can calculate. So here cos square x is there. Here also we have to use the trigonometric formula. So cos square x equal to, we can write 1 plus cos 2x by 2. 1 plus cos 2x by 2. So here 1 plus cos 2x by 2, if you replace here, 1 by 2 is the constant, plus 1 by 2 into cos 2x. So 1 by 2 into, this is the constant. In the same way like a previous problem, we have to replace e power 0x. For the cos x formula, we have to follow. So in the same way for the sin x and sin 2x also, we have to follow the trigonometric formula. After then, we have to split the given equation. So here also, and sin 4x and sin x also, we have to use here 2 sin a, sin b formulas. So already we discussed about the method of variation of parameters here. So in the same way we can calculate 12th problem and 13th problem also by using the method of variation of parameters. For all these questions, we can refer these textbooks and we can get the solutions properly, and please practice the more problems take from these textbooks. So the references books are Higher Engineering Mathematics written by B.S. Cravel, and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Higher Engineering Mathematics written by B.V. Ramana, and one more textbook for the basic formulas. You can use this, Engineering Mathematics written by T.K.V. Iyengar. This is S-Chan Publications. These are all textbooks you can take and take the more examples to get the solutions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.